All right, alkanes from the previous slide. Down below you see alkanes and the definitions. They are aliphatic hydrocarbons that have the general formula C subscript N or C base N. Okay, CN H2N plus 2. What does that tell you? It tells you that it tells you that N is an integer. All right, so if I put N to be 1, for example, you have C1. Okay, N is not starting. Okay, N is starting from 1. Okay, so C1, that will be H4 from the formula CN H2N plus 2. It's on the screen. So you have C1H4, that CH4, that's the first member of the alkane series. It's called methane. Met. When N is 1, you have met. When N is 2, you have ethane, that's C2H6. When N is 3, you have propane, C3H8. When N is 3, you have prop. When N is 4, you have but. Take note, for any compound you are naming, whether aliphatic or aromatic, acyclic, cyclic, when N is 1, you have met. When N is 2, you have et. When N is 3, you have prop. When N is 4, you have a but. When N is 5, then you have pent, like your normal, the way you name your polygons now. When N is 5, you have pent. When N is 6, you have x. When N is 7, you have ep. When N is 8, you have oct. When N is 9, you have non. When N is 10, you have dec, just like that, like that, like that, like that, like that. Now look at the from alkanes. You have the concluding, the difference, sorry, and the concluding note there. The difference among series of organic compounds with the same functional group is called the homologous series. I think I need to pause now to explain what a functional group is. The functional group is a group of compounds, all right, or a radical. A radical. Well, we're being taught in SS1 that a radical is an atom or a group of atoms carrying electric charges. All right, a group of atoms carrying electric charge. For example, you have OH, then raised power minus. That's hydroxyl. Okay, that's a radical. So a functional group is a radical attached. Okay, it's a radical attached to um organic compounds. Okay, that specifically determines the chemical properties of that compound. As we go on, we'll see more analysis on the functional group. So I just let me just give the definition of that. That's the meaning of a functional group. So the difference among series of organic compounds with the same functional group is called what? The homologous series. The difference. If you check the methane, the ethane, the propane, the butane, check their formula CH4, C2H6, C3H8, C4H10. You see that the difference between each of them is CH2. The difference between each of them is CH2. So when you have a family of organic compound like that, the difference between each members is CH2 group. The difference between each successive members is a CH2 group. That compound, what is happening there is what I call the homologous series. That series or that setup is called a homologous series. So that's what homologous series is about. Family of organic compounds in which each successive member differ by a CH2 group. So that is what alkane is all about. The same thing is applicable to alkenes. All right, the notes are there. The same thing applicable to alkynes. Alkenes have the general formula CnH2n, while alkynes have the general formula CnH2n minus 2. All right, don't forget, one is met, 2 et, 3 prop, 4 but, like that, like that, like that.